Hello dear friends, welcome to the second video lecture on the chapter on isometric projection. So in the first lecture we already discussed on the introduction part and we did a problem on combination of solids. Today we are going to draw the isometric projection, going to do two problems, one of a prism and the second one of a cylinder. So let us start with the first problem. So here is the question. Draw the isometric projection of a pentagonal prism of base side 30 mm and height 60 mm, resting on its base on HP, and one of the rectangular face is parallel to VP. So as we know, a pentagonal prism will be having two pentagonal faces, the bases, whereas lateral faces, if you are taking, there will be 5 rectangular faces. So in this case you can see that one of the rectangular face is made parallel to VP and it is resting on its base on HP, so which means that the solid is going to rest like this on its base, and one of the rectangular face, which means that one of the edge in the top view is going to be parallel to VP. Okay, so the question is to draw the isometric projection. So projection means you need to draw it according to the isometric scale. So in the last class we have already learned how to draw the isometric scale. If you are here in this question, if you take the highest dimension is going to be 60 mm. So I am going to draw an isometric scale for 60 mm length. So for that I will draw 60 mm in the true scale, 0, 10, 20, 30, 40, 50 and 60. At 0 I will be drawing a line with an angle 15 degrees, and at 60 I am drawing a line with angle 45 degrees, which we have already discussed in the previous lecture. So 60 is one dimension which is coming in this question, and the second dimension, that is the base side of 30 mm. So in order to get the length ISO 30, what you have to do is, based on this edge, this side, you have to draw a parallel through 30 to meet this adjacent edge. So this length is going to be your isometric 30, and this full length will be your isometric 60. So let's draw the orthographic view first. So okay, let's draw the isometric view first. So I'm drawing the XY line first. So as we know in this question, in the top view, one of the rectangular face, that is one edge, is going to be parallel. So parallel to the XY line, I will be drawing one edge parallel to XY line. So this is one edge made parallel. So the length of this parallel edge, this edge, base edge, as you know in the question it's 30. So but you have to draw not with the actual 30 length, but you will have to take that isometric 30 length. You have to take that ISO 30 length and you have to transfer it over here. So this is ISO 30. So one edge has been completed. Now in order to complete the pentagon, we know that the interior angle of the pentagon is going to be 108 degrees. So you take 108 degrees over here and you draw the second edge. So this is going to be your second edge. Similarly, next you take 108 degrees again, so you will get your third edge. You take 108 degree again, and finally in this way the pentagon has been drawn with one of the base edge parallel to the vertical plane. So all the lengths you have to take not as 30 but isometric 30. And how to locate the center of the prism, how to locate the axis So for that, what you do is you can take half of that 108 degrees, that is 54 degrees. So you can take 54 degree here, okay, and you can take 54 degree here. So it will intersect at this particular point. So this is going to be your axis, which is going to be OZ. So OZ is your axis. So we have located the axis. Now moving on to the front view. So let us name the 5 corners of the base. So let it be A, B, C, D, E. Okay. Now we are going to draw the front view. So for that, I am going to draw the projectors through A, through B, through E, through C, and through T. And as we know, this is a prism. So this is going to be the base. And what is the height of the solid? The height of the solid is given as 60. But instead of 60, you will have to take this length, that is isometric 60, and you can take that height, isometric 60, and you can complete the front view of the solid. So this is the vertical edge in the front, this is the vertical edge at the right. So this is the height, which is isometric 60, and regarding the 2 edges which is at the back, that won't be visible in the front view, so that is represented as dotted lines. Okay, so the base edges are going to be A dash, this is your E dash, this is your B dash, C dash, and E dash. So let's also name the top base edges. So above A, let it be B dash, above B, let it be Q dash, above C, let it be R dash, above D, let it be S dash, and above E, let it be T dash. So these are the 5 plus 5, 10 corners of the solid. So we have drawn the isometric, the orthographic view. Now let's draw the isometric projection. So for that, we need a reference or a salient point. So what we do first is we will enclose this solid in an imaginary box. So this pentagon is contained in an imaginary box. So this is the rectangular box inside which this pentagon is contained. So let's name this corner of this imaginary box as 1, 2, 3, and 4. Let us take the cyclic order 1, 2, 3, and 4. So this is the front view of the solid. So in the front view, the top view of the solid. So in the top view, this plane will be your XY plane. So this direction is your X direction, this will be your Y direction, and all the height from the ground will be your Z direction. So for drawing the isometric view, first let's start by drawing the base. Okay, we have drawn the base, and as you know, the X and Y is going to be at an angle of 30 degrees. So let's take the left corner bottom point as your reference. So I am taking 1 as my reference. Okay, the salient point 1 as my reference, and I am drawing 30-degree line. So one 30-degree line to the right and the other 30-degree line to the left. So this 30 degrees has to be shown, which is very important. So this is going to be your X direction, this is going to be your Y direction, and this vertically upward will be your Z direction. So you are going to draw this pentagonal prism, and for the ease of doing that, we are enclosing it in a box. So this is the box having the base corners 1, 2, 3, 4. So that will appear as a lamina, rectangular lamina. So we have drawn one first. So from next we are going to move in the X direction. From 1 If you are moving in the x direction, the next point is 4. So what you have to do is you have to take the distance from 1 to 4. You have already, please note that this has been drawn already using the isometric scale, because the question was to draw the isometric projection. So this has already been drawn with isometric scale. So you take this distance 1 to 4 and you mark it here. So this is your point 4. So this is taken in the x direction. Next, from 1 to 2, the travel is in the y direction. You take the distance 1 and 2, between 1 and 2, keep the composite 1 and you get the point 2. Next, from 2 to 3, so from 2, what you do is you draw a line parallel to this, and through 4 you draw a line parallel to y. So this will be your point 3. That will automatically be your point 3, or otherwise what you can do is you can take this distance 2, 3 and you can cut an arc over here, 3, 4 and you can cut an arc over here. It's going to be the same point only. So this is the bottom base. Now the top base. In order to draw the top base, so we know that the distance between the bottom base and top base is going to be that height, ISO 60. So what I'm going to do next is I'm going to take this ISO 60 length and mark it upwards from 1, 2, 3 and 4. So you take ISO 60 from 2, ISO 60 from 1, ISO 60 from 3 and ISO 60 from 4. So this is going to be the top base of the solid. This is going to be the top base of the solid. Okay. So let's name those points as 5, 6, 7 and 8. Okay. Now, so the next step is pretty simple. You have to locate this 5 points of the bottom base on this square 1, 2, 3, 4. So first, what is the location? Where is the location of A? A is located in between 1 and 2 at a distance of 1A from 1. So you take this distance, measure this distance and you mark it on 1, 2 from the point 1. So you take this distance and you mark it over here. So this will be your point capital A. Next, on 2, 3 you are having 2 points B and C. So this is your 2, 3 and on that you will be having B as well as C. Now how to locate it on the isometric view is you take the distance from 2 to B, the small distance, and you mark it over here. So this is going to be a point B. Next you take this small distance from 3 to C here, from 3 backwards. This is going to be a point C. Next, D is going to be at a distance of 4D from 4. You take this distance and mark it over here on 3, 4 over here. So you take this distance and mark it over here. So this is your point D. And finally E. E is going to be, before that, let's mark the top view points of the top base. So above A is going to be P, above B is going to be Q, above C is going to be R, above D is going to be S, and above E is going to be T. Okay, so finally the bottom point E is located between 1 and 4. So you take this distance 1E and you mark it over here. This is the point E. So we have got all the 5 points of the base. So this is the pentagonal base at the bottom. Now to get the pentagonal base of the top face on the top square 5, 6, 7, 8, you apply the same procedure. Just like what you applied over here on the base. So applying the same procedure, above A you will get the point P, above B you will get the point Q, above C you will get the point R, above D you will get the point S, and above E, you will get the point T. You join the 5 points, so the top base is anyway going to be visible in your view. So the top base has been drawn. So the bottom base, let's start drawing the edges. So these three edges will be visible in our view. After that, let's draw the vertical edges. So these are the vertical edges. You can see that the 4 vertical edges will be visible in the view, whereas the 5th vertical edge, CR, it is not visible in this particular view, so that is drawn using dotted lines. And finally, the other 2 base edges can't be seen, so which is drawn using dotted lines. Now finally, how to represent the axis. So axis, as you know, it is going to be it's not going to be on AD. It's not going to be on AD, but what you have to do is you have to draw a parallel line through E. So it is not on OD. You have to draw a parallel line through E, parallel to Y direction. Okay, and on that line you get this distance from E to O. E to O is it. So you get this distance and you mark it over here. So this is your point Z. Your point Z. Now apply the same procedure above. You draw a line through T parallel to Y axis. Get this distance from T to O and you mark it over here. So this is going to be a point O. So O and Z, it is the axis, so that is drawn using the chain line. Chain line is used to represent the axis. And finally, one more thing, you have to show the dimensions. So this is your this side, this length is of, it's of no use, there is no significance because the length is not given. So next what you're going to draw is next is this edge. It's going to be ISO 30 as given in the question, and whereas this height of the solid is represented like this, the height as ISO 60. So this is the problem on isometric projection. So next problem is to draw the isometric projection of a cylinder. So let's read the question first. Draw the isometric projection of a cylinder of diameter 40 mm and 50 mm height, lying on one of its generators on HP with the axis perpendicular to VP. So you are having a cylinder, the dimension is given as 40 mm diameter and 50 mm height, lying on one of its generators. So as we know, these are all the generators. So it is lying on one of its generators, and the condition is that it's lying on one of its generator on HP, and the axis, what they have said is the axis is perpendicular to VP. So which means that, so let's draw the orthographic view XY. So the solid, the axis is going to be perpendicular to the vertical plane. So this is your vertical plane in the top view. So the axis is not parallel, but indeed it's going to be perpendicular. So this is the top view of the solid. Okay, and the front view of the solid is going to be like this. This is the front view, and this is going to be the top view based on this given parameter in the question. So it's very simple. The solid is lying on the ground. so on one of its generators. So in the front view, you just simply draw a circle. You simply draw a circle. The circle, what is the dimension which you have to take? Is it 40? No, it is not 40. Instead of 40, you will have to take, the diameter is given and the question has 40. So you have to take isometric 40. So the construction is, as we have already discussed, first you draw a 15-degree line at 0 and you draw a 45-degree line at 60. So this is going to be your isometric. Based on this true 60, this is going to be your isometric 60 length, and based on the true 40, you draw a line through 40 parallel to this edge. This small length is going to be your isometric 40. So you take this length, this particular length, as the diameter. So the solid is drawn with diameter of isometric 40. Isometric 40, and this is going to be the top view of the solid. Okay, this is the axis. Okay, so let's name the axis as OP. Let's name the axis as OP. So this is O dash P dash in the front view. So before starting to draw, all you have to do is you have to draw this in an enclosed box. So solid is enclosed in a box. So let the corners be 1, 2, 3 and 4, and the corners at the back be 5, 6, 7 and 8. So what is the length which you have to take? The length of the solid is 50 mm. Height is 50 mm. So this length is going to be isometric 50. So you draw the base. So 1, 2, 3, 4 is the front side of the box. So you take 1 as the reference. You draw the x direction with angle 30 degree. You draw the y direction with angle 30 degree, and you draw the z direction with angle 90 degree as usual. So this is your x, this is your y, and this is your z in the isometric view. Whereas in the orthographic view, this surface, on the surface in the top with the base, this is going to be the x, this is going to be the y, and this height from the ground is going to be your z. Okay. So 1, 2, 3, 4. So 1 to 2, the direction is z direction. So 1 to 2 in the z direction, the height. So this isometric 40 you will have to take over here. So this is your point 2. Next 1 to 4 in the x direction. 1 to 4 in the x direction. You take 1, 4 length and you mark it in the x direction. So this is your point 4. Next 2 to 3 and 4 to 3. You take that length parallel to x, you draw a line through 2. Parallel to z, you draw a line through 4. So this will be your point 3. So this is the front face, rectangular face, square face of the cylinder, of the box. Now it is extending backwards from this face 1, 2, 3, 4 to the back square face, which is 5, 6, 7, 8. So from 1, 2, 3, 4, it is extending backwards. So what is the length? It's going to be ISO 50. So you can take this length in the y direction. So this is your point 5. Next through 4, you draw a line. Next through 5, you draw a line. Through 2, you draw a line parallel to the y direction, and next through 3 you draw a line parallel. So from 1 to 5, the distance, this distance is going to be ISO 50. You will get your 0.5. From 2 to 6, same distance, is your 0.6. From 3 to 7, the same distance, this distance from 3 to 7, and this distance from 4 to 8 is going to be like this. So this is the back square of the box. Back square of the box. Okay. So you have to draw a cylinder inside this box. Okay. So the front circle is lying on the face 1, 2, 3, 4, and the back circle is lying on the face 5, 6, 7, 8. So let this intersection point be A, B, C and D. So A, B, C and D are the midpoints of 1, 2, 2, 3, 3, 4 and 1, 4. Okay. So where is the point A? A is the midpoint of 1 and 2. So in 1, on this edge 1, 2, you locate your point A. On 2, 3, you locate the point B. On 3, 4, you locate the point C. And on 1, 4, you locate the point D. Similarly, the circle will be touching the square at the back. So let those points be P, Q, let the axis be OZ. Okay, we are taking this point P over here. So let's the axis be OZ. Okay, so in the back face the points are going to be P, Q, R and Z. Okay, so P, Q, R and Z are on the back side. So P will be the midpoint of 5, 6, Q of 6, 7, R of 7, 8 and P, Q, R and S of 5, 8. Okay, 5, 8. So in the same manner which we followed in the front, you locate the point. So P is between 1 and 2. You take this distance and you mark it over here from 5. So this is your P. On 6, 7 you have your Q. On 7, 8 you have your R. And on 5, 8 you have your S. So the front circle is going to be like this and the back circle is going to be like this. So this circle will be appearing as an ellipse in the isometric view. If you are joining it like this, the curve through ABCD, you can notice that it is going to be an ellipse. So how to draw this ellipse or how to draw isometric circle? So for that, the procedure is very simple. So just look at this square. So what is the shape of the square now? It was actually a square. Okay, 1, 2, 3, 4. The square, in the isometric view, it has turned into a rhombus. Okay, 1, 2, 3, 4. So the procedure is very simple. So you draw diagonals through 1 and 3 and 2 and 4. Okay. Now this is the major axis and this is the minor diagonal. Major diagonal and the minor diagonal. So the next thing is, I am just rotating the figure. So this is the major and this is the minor diagonal. What I have to do next is the corners of the minor diagonal, which are 2 and 4. So what you have to do is, from this 4, please pay attention, this is very important. From this point 4, you have to connect to the opposite midpoints, that is A and B. And similarly, the other corner 2, you have to connect to the other opposite two midpoints, that is D and C. So you can see that you'll be getting two centers over here. Let us name the centers as O1 and O2. Okay. So to draw the ellipse, it's very simple now. So you take this distance 4A. So you can notice that this distance 4A is going to be equal to 4B. Okay. So what you do is you take this 4A length in compass and you draw an arc. It will definitely pass through B. So you keep the compass at 4, take the distance 4A and you draw an arc. You get it like this. Okay. Similarly, next procedure is you keep the compass at 2, keep the compass at 2, take 2C as the distance and draw an arc. It's going to be like this. Okay, so the two sides are complete. And how to complete this AD and BC is very simple. Keep the compass at O1. Now it's the turn of O1 and O2. Okay, you keep the compass at O1. Take this small distance between A and O1. This small distance. You keep the compass at O1 and take this radius O1A. Keep the compass here and you draw the arc like this. You draw the arc like this. So keeping this as center and this radius, you draw an arc. It will be like this. Similarly, next you keep the center at O2. You take this distance O2 to B as radius and draw the arc. So this method is called the 4-center method. The 4-center method to draw an ellipse. So we know that the circle is going to be going to appear as an ellipse in the isometric projection. So how to draw the isometric circle is what we have discussed right now. So this is the front circular face which will appear as an ellipse. Okay, now the back circular face, you apply the same procedure as we said, the major diagonal, the minor diagonal. From the minor diagonal vertex you connect to the opposite midpoints. From 6 you connect to S, and from 6 you connect to R. You have O3 and O4. Okay, O4. You repeat the same procedure which we did earlier. Okay, so you will get the back rectangular face. Pardon my figure, it's not legible, neat. So we can draw it using scale with the actual true length, so you will get the figure properly. So this is the front face and this is the back face. Now the final step is to just draw the lateral faces. So the lateral faces is drawn by just drawing diagonals. Okay, just drawing tangents. Draw a tangent over here and you draw a tangent over here. Okay, you draw a tangent over here and you draw a tangent over here. So in this manner you can draw the cylinder, and finally you will have to show the dimension. So this dimension is going to be ISO 50. This dimension, this is the length of the cylinder, and it is going to be ISO 50. Sorry, this is ISO 40. Okay, this is ISO 40 and this is ISO 50. So this was about today's lecture. So today we discussed how to draw the isometric projection of a prism and a cylinder. Thank you. And one more thing, we will have to locate the axis. So for that, join AC and BD. You will get this center point. This is your point O, and join PR and QS. This is your point EZ. You join O and AZ. This is going to be your axis. Okay, this is going to be your axis. And taking the back face, this edge up till here, it is going to be visible, whereas the portion at the back is going to be covered. So that is drawn using dotted lines. Thank you.